Hi, hello students, welcome back to our channel. This is Bhaskar Bora. We are discussing 5th chapter quadratic equation from 10th class mathematics. Now let us see the 4th problem from second bit. It is given as a train travels a distance of 480 kilometers at a uniform speed. If the speed had been 8 km per hour less, then it would have taken 3 hours more to cover the same distance. We need to find the speed of the train. A train is covering 408 km distance with uniform speed. Uniform speed means it is maintaining the same speed. So if the train travels that 408 km distance with the same speed, it takes some time. And suppose if we reduce the speed of this train to 8 km per hour, then the time taken by the train to travel this same distance, it takes 3 hours more time when we compare with the previous situation. So here, if the speed of the train is reduced to 8 km per hour, then the time taken by the train is 3 hours more than the time taken by the train when it is travelled with the uniform speed. Now we need to find the uniform speed of the train. So here we have to assume the uniform speed of the train with one variable. So let us assume the uniform speed of the train as x km per hour. So the uniform speed of the train is x km per hour. And what is the distance that is covering with this speed? The distance travelled by the train is 480 kilometers. To cover this 480 kilometer distance with the uniform speed x km per hour, how much time does it will take? So the time taken by the train to cover the distance 408 kilometers with the speed x km per hour is, let us take this as t1. T1 equals to, so what is the formula for finding time when we have speed and distance? So it is distance by speed. So distance equals to 480 by x. So 480 by x hours is the time that is taken by the train to cover the 480 kilometer distance with the uniform speed x km per hour. Now next, what happened? The speed of the train is reduced to 8 km per hour. So after reducing the speed of the train 8 km per hour, then what is its new speed? For that we need to subtract 8 km from the uniform speed x km. So we get the speed of the train as x minus 8 km per hour. Now with this speed it is covering the same distance, that is 480 kilometers. Now to cover the same distance 480 kilometers with the speed x minus 8 km per hour, what is the time does it take? So to find this, let us take the second time as t2. So t2 equals to distance by speed, and here the distance is 480 by speed is x minus 8. So the second time we get as 480 by x minus 8 hours. So 480 by x minus 8 hours is represents the time that taken by the train to cover the distance 480 kilometers with the speed x minus 8 km per hour. Now this time, the second time, it is 3 hours more than the time that is taken by the train in the first case. So what is the time in the first case? We have t1 equals to 480 by x hours. It is 3 hours less than this second time. So we can write t2 equals to t1 plus 3, since the second time is 3 more than the time taken by the train in the first case. So here if we substitute t2, t1 values, we get 480 by x minus 8 equals to 480 by x plus 3, and on the right hand side if we simplify we get 480 plus 3x by x, and if we do cross multiplication we get 480x equals to 480 plus 3x into x minus 8, and on the right hand side if we multiply we get 480x plus 3x square minus 3840 minus 24x. And if you observe this equation, on both sides we have the equal term, that is 480x, so we can cancel it. So we get 0 equals to 3x square minus 24x minus 3840 equals to 0, which can also be written as 3x square minus 24x minus 3840 equals to 0. And if we take 3 as common out, we get x square minus 8x minus 1280, which equals to 0. By transposing 3 to the right hand side, we get x square minus 8x minus 1280 equals to 0. So this is the required quadratic equation to represent the given situation, and here x is the uniform speed of the train. And we will meet in our next video with the next concept of this chapter. Till then, bye. Thank you.